Oh, sorry. Didn't see you there. Welcome to Mind of Meaning. Thank you for joining me. Let me tell you a little bit about myself. I'm just a regular guy. I do regular things. I have a wonderful girlfriend. I have a couple very mischievous cats. And I have a decent place where I live. One thing I like to do is I like to learn new things. And, well, when you learn new things, you're dealing with information. And when you're dealing with information, you're dealing with data. So I've been told. Okay? So you learn a new thing, there's information, and there's data. But what is data? What is it made of? What makes data data? I could tell you what I think, but I think it would be more fun if we went on a journey together and try to figure it out. So today on Mind of Meaning, you, me, the whole world, the whole universe is going to go on a journey to what is data. And we're going to start where every good journey, learning a new thing, should start, has to start, must start. And that is Wikipedia. Okay. So, I've got the Wikipedia page pulled up here. And we're just gonna, this is a little obnoxious. Okay, I've got the Wikipedia pulled up. We're gonna read it. And then we're gonna see what we can collect in terms of a definition, like something we can work with, some basic sort of working definition. Can I be more redundant? Probably, maybe, perhaps, perchance, a little bit. Okay, we're gonna go through here and see what we can parse out from data. So we're just gonna read it. We're gonna read it. And I got my handy dandy notepad, trademark. Don't come after me, Blues Clues. Got my handy dandy wrong screen notepad right here. And let's just see what we can collect, huh? Okay. So we're gonna read it. I'm gonna read it to you. In common usage and statistics, data is a collection of discrete or continuous values that convey information. Remember what I said, information made of data, right? So a collection of discrete or continuous values that convey information. Describing the quantity, quality, fact, statistics, other basic units of meaning. Oh, hey, there's the key word right there. Keyword. Notice the title of the channel, Mind of Meaning, right? So maybe we're on the right track to something. Okay? So, or simply sequences of symbols, like the alliteration, that may be further interpreted formally. So once again, in common usage and statistics, data is a collection of discrete or continuous values that convey information describing the quantity, quality, facts, statistics, other basic units of meaning, or simply sequences of symbols that may be further interpreted formally. A datum is an individual value in a collection of data. Data is usually organized into structures such as tables that provide additional context and meaning, and which may themselves be used as data in larger structures. Data may be used as variables in a computational process. Data may represent abstract ideas or concrete measurements. Data is commonly used in scientific research, economics, and virtually every other form of human organization activity. Example of data sets include price indices such as consumer price index, unemployment rates, literacy rates, and census data. In this context, data represents the raw facts and figures from which useful information can be extracted. Okay, that, I don't know about you, but to me, kind of feels like a lot, doesn't it? And I wonder if we can dive a little deeper here and see if we can get a better idea of what all of this means. Okay, so let's see if we can parse it out. I'm going to pull up my handy dandy notepad, and I'm going to say definition of data, right? And then what I'm going to do is I'm going to just grab this pretty little Wikipedia link here. I'm just going to slap that on the floor, on my notepad. And then I'm going to use my handy dandy Control C and Control V. Now I have a bunch of words on a page or on my little notepad. Now what I'm going to do is be a little discreet here. Be a little discreet. I just want to save this. All right, and we're back. Okay, so in common usage and statistics, data is a collection of discrete or continuous values that convey information, describing the quantity, quality, facts, statistics, other basic units of meaning, or simply a sequence of symbols that may further be interpreted formally. There's a lot here. Okay? And maybe what we need to do is take a little side jaunt, take a little detour, take a little venture into maybe someone who can explain it a little differently. So I got this YouTube video pulled up. Seems appropriate, right? And hopefully my sound is working correctly. And we can see what the University of Houston Libraries has to say about this. I'm going to just play this 2-minute and 12-second video, and maybe we'll learn a little bit more. You know? No sound yet. Oh, I love that for me. Okay, so apparently my sound isn't coming through. What if I do that? Nope, still not coming through. You know, technology is a wonderful thing. Here's what I'm gonna do. Do the classic on and off. Let's see if that works. Nope, still doesn't work. All right, bear with me, people. You know? It sure would be nice if things would work out sometimes, but sometimes in life, you can't get what you want. We're just doing a bit of
and sold.
there we go.
But what exactly is data?
Okay. That's what we needed to do. Just needed to shift some things around here. In the old OBS doesn't always have its noggin working, but we're not going to hold that against OBS because we suffer from the same problem as well. And by we, I mean myself. This person right here. Okay. Once again, what is data? Let's see what the University of Houston has to say.
What is data? Brought to you by the University of Houston Libraries. We hear the word data all of the time. It is collected, analyzed, shared, hacked, bought, and sold. But what exactly is data? Data are collected observations or measurements represented as text, numbers, or multimedia. When we think of data, we may immediately think of numbers, but data can also be field notes, videos, audio recordings, photographs, documents, and transcripts. What you consider to be data will be different depending on your area of research. For example, if you're researching the impact of wildfires on national parks, your data may be satellite maps and images. But if you're researching graduation rates of college students with faculty mentors, your data might be the number of graduates each year and the amount of time taken to earn their degree. Data will be different based on what you study. Data can be broadly categorized as qualitative or quantitative. Quantitative data can be expressed as a number and counted or compared on a numerical scale. This would include such things as rating scales from surveys, temperatures observed, or measurements gathered. It could also include things like counts of words used in a book or the number of attendees at an event. Qualitative data include things like textual descriptions of events, maps, pictures, or transcripts. There are other ways to categorize data, but most fall in one of these two broad categories. Data are not the same as statistics. Statistics are the result of data analysis and interpretation, so be sure not to use the two words interchangeably. Analyzing and interpreting data can help you identify patterns and trends, offer solutions to complex problems, or better understand scientific phenomena. Data are powerful aids in our attempt to understand the world. If you want to learn more about finding, accessing, and using data, visit the UH Library's Finding Data Guide.
Okay, so what did we learn from this video? We learned that data is stuff you collect about things using, well, in this case, they're talking about like the use of your senses, I guess. That can be data. It can be, well, they said there are two types of data, right? They said quantitative or qualitative. And then they said, well, these are what there's, okay, so. Forgive me, people. My brain is a little all over the place. Here we have another definition. So we're going to just pull up our handy dandy notepad, and we are going to copy this as well. Definition of data. I'm just gonna from Wikipedia, definition of data from University of Houston Libraries. And I'm gonna grab the link as soon as I'm done copying this down. They say data is collections of, collected observations of or measurements represented as texts, numbers, or multimedia. Represented as measurements, numbers. Sorry, not measurements. Listen, it's early here. Leave me alone. Texts, numbers, or multimedia. Okay, so here we have another data, and we're going to be responsible
Observations
internet.
or measurements represent.
Shut up. We're going to be responsible internet denizens, citizens. We're going to grab that link, and we are going to just slap it right there. And then we're going to Control S to save it. All right, now we can find this again when we need it again. But this is a very concise definition here. And now what we can do is we can take a little look at what we've collected from our internet perusal, our internet venture. I love how my microphone is over here, so the sound is going to be way off, but I don't want to have this here because then you won't be able to see me. So it's just my active thoughts, okay? So let's take a look. Okay, so we got the Wikipedia definition. In common usage, the statistics data is a collection. So we're talking about common usage here and statistics. Data is a collection of discrete or continuous values that convey information describing the quantity, quality, facts, statistics, other basic units of meaning, or simply sequence of symbols that may be further interpreted formally. That appears to be the Reader's Digest version of the Wikipedia article. So we're going to just sort of encapsulate that, right? Away from the other stuff. I just use parentheses there just to sort of underline it, because you can't really underline in Notepad. If you can, I don't know how to do it. You probably can. Okay, so discrete or continuous values that convey information describing the quantity, quality, facts, statistics, other basic units of meaning. Or simply sequence of symbols that may be further interpreted formally. And then here from the University of Houston Library, data is collected observations or measurements represented in text, numbers, and multimedia. What have we learned here? What do these things have in common? We've got discrete continuous values that convey information. All right. So it seems to be the case that in order to understand data, we need to have a good definition of what information is, because presumably information is made of data, right? So the way I kind of think about it is data is the ore and information is the refined product. It's been processed, it's been interpreted, it's been normalized, it's been fiddled with so that it's useful. Okay, this is a good start. I think we're on to something. We're getting there. Okay, so that I told you my definition. I want to just write down my definition so we have that down. Mind of meaning definition, which is an analogy. An analogy. Data is the ore, information is the refined product. Or so I say. But is that really true? Well, before we get to that, I had this other video pulled up, and it's from Computer File. And they're pretty good. I mean, like, you know, supposedly we live in the information age, right? And the reason we call it the information age is because we use computers a lot, right? We're using computers. Love computers. Use them all the time, right? So here we've got Computer File, which is a good little computery channel. Very popular. 2.34 million. Almost as popular as I am, right? And they're going to go ahead and tell us what data is. I haven't seen this. I haven't pre-watched. Okay? I haven't pre-watched. We're going to see if this is any good. We're going to watch Mr. Guy here tell us about a little data analysis and what data is. And maybe we'll pull a better definition out from the experts of the information age, huh? Let's find out.
What is data, right? I'm pretty sure that's data.
Can you people hear that?
Right? Is this data? You know, this picture? Or that data? Is this data? What is data? So we talked a lot about data in the last video. Why is it important that we can analyze and understand data? But what is data? Everybody has data. Everybody's generating it. Companies are generating on us. We're generating it ourselves, you know, when we use social media, so on. But what is it? And understanding what it is a prerequisite for being able to use it properly. Perhaps the most important thing as far as we're concerned, so people who are trying to analyze data sort of scientifically, is that data has to be measurable, right? So the idea is, you know, if you're going to do a survey on what people like, everyone's got to be using the same scale and the same rating system. Otherwise, it doesn't make any sense, right? We can't have someone rating things from 1 to 5 and someone else saying, I thought it was good, right? Because which one of 1 to 5 is good? We don't know, right? So everyone's got to be doing the same thing. Your data's got to be a consistent format. And once that's achieved, at least we're a little bit closer to be able to make some sense of it. Broadly speaking, when we talk about data, we kind of have 4 different types. And we summarize this with this nice noir word. So N-O-I-R, noir. And each of these different types of data, we can do different things with, right? So N, that's the first type. So this is nominal data. The nominal data is where we have no distance between the values that we can measure, right? Because they're not really.
So we're going to watch the whole thing through, and then we're going, well, I kind of want to watch the whole thing through, but I kind of want to grab these things as we're going along. Seeing as there's nobody here right now, I'm going to just grab it while we go along. Thank you for bearing with me here. Hours and hours of entertainment, you know? Hours and hours of entertainment. This is top tier content right now. Okay? You don't know what you're getting right now. This is the best content on the internet. The best content on the internet right now. And you get to watch it. Aren't you lucky? Aren't you absolutely lucky? Okay. Whoa. 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 Forgive me. That's been happening a lot lately. Okay, so we're gonna call this computer file definition of data. And they use an acronym. N-O-I-R. NOIR. And the first thing is
Really quantities, and we
nominal. So we're gonna say nominal. And then we're gonna see what he says about it. Nominal. Hello?
can't order them. So a good example would be colors. So maybe you have your favorite color is red and my favorite color is blue. I don't know. Which is better than the other? There is no measurement between them, right? Is blue closer to green than red is? You know, that doesn't make any sense, right? We're not talking about wavelengths. We're just talking about the colors, right? Another good example would be, let's say in football, player numbers on your back, right? Now, symbolically, sometimes certain player numbers have a meaning, but you can't compare and contrast them. You can't say that 8 is 2 times better than 4, right? That doesn't make any sense, right? You also can't really order them in general, right? Player 16 doesn't go before or after player 13 in a list. That doesn't make any sense, right? So nominal data is data where, and it's useful, right? It could be really important, but it's data where we kind of have labels, but no way of ordering these labels. So you can still analyze it, but you can't, for example, calculate the average, like the mean average, right? That wouldn't make any sense. What you can do is calculate the mode. So you can calculate the most common one. So you could say that more people prefer red to blue, but you couldn't say, you know, the average color that people like is a sort of muddy brown, right? That doesn't make any sense at all, right? So as we go down this list, we get slightly more and more informative, in some sense, types of data. So the next one is ordinal. So in ordinal data, we have an order, but we can't measure distances between things. So a good example would be something like positions people finished in a race. So, you know, maybe I finished first, I'm super quick, right? You didn't, you finished third, but how?
All right, what did he say?
So, you know, maybe so a good example would be something like positions people finished in a race. So, you know, maybe so a good example. So in ordinal data, we have an order, but we can't measure distances between things. So a good example would be something like position.
Has an order, but can't measure distances between things. Okay. Ordinal. Has an order, but can't measure distances between things. So, and he gives example of positions in a race. There.
People finished in a race. So, you know, maybe I finished first, I'm super quick, right? You didn't, you finished third. But how far we are apart, that isn't included in that kind of data. You'd have to have a separate value for that. Another example that we're all familiar with is rating systems, right? So perhaps I rate a film from 1 to 5 stars, and you rate the film from 1 to 5 stars. But you can't really say that a film that scored 4 stars is 2 times better than one that scored 2, because that's very subjective, and there's no real sort of measurable distance between these stars. If you have ordinal data, you can calculate the mode. Again, you can calculate the most common value of all the values that were returned, or you can calculate the median, the one that sits in the middle, right? So maybe, you know, 50 runners in a race, the 25th position, roughly speaking, is going to be, you know, around the median. So it's still not hugely useful, right? But next up, we have interval data. Interval data, we have an order, and we have...
It's interesting that he says it's not useful. I sort of wonder what he means by that. We won't follow that thread right now. Let's just keep going through it.
a distance, but we have no sort of absolute zero for this scale. So a good example would be something like degrees Celsius, right, or degrees Fahrenheit. 0 degrees Celsius isn't no temperature, it's a specific temperature, right?
Fahrenheit.
So we can't say that 50 degrees is half of 100 degrees. No sort of absolute zero for this scale. So a good example, and we have a distance, but we have no sort of absolute zero for this scale.
Okay. Has an order and a distance, but no absolute 0. So I guess where he's gonna go with this, whatever the last one, the R, is that gonna point? So he gives this example of degrees in Celsius, right? Fahrenheit and Celsius. Is he gonna say Kelvin is gonna, like, the degree scale Kelvin is gonna be whatever this thing, this R down here is? Here, let me. It's starting to get a little muddled. Interval. You know, I wonder where he's gonna go. So we've got, there's no absolute 0, but there is an order and a distance. Now this feels very different from the other two definitions, doesn't it? He seems to be focusing on the value primarily of like numbers, of like the what we can measure, the degree to which we can measure a thing, right? So he seems to be valuing more the measury kinds of data, more so than the labels, like the nominal stuff, as he says it. Woof. Are you still with me, people? Are you still with me? This is a lot. I mean, holy cannoli, you know? Holy cannoli, like, this is a lot of stuff. I mean, okay. After we finish this video, okay? After we finish it, I want to just do like a little bit of a review of what we've got so far, okay? We'll review it and see if we can like put it into our own words and make it a little more ours, okay? I like how my camera was like picking up on my fist. It's like, your fist. Anyway, so just thought we'd take a little moment. It's a lot of stuff. Hi, how are you doing? Are you doing well? Can you even hear me? Is there anybody out there? Pink Floyd? Take a breath. We can do this. You and me. We're gonna, by the end of today, we're gonna understand something about data, okay? At least one thing about data, all right? And we've already kind of accomplished that. So that's, you know, kudos to us. Way to go, us. Okay. Are you ready? We're diving back in. Bam. Watch my sound get messed up again.
So a good example would be something
Perfect.
like degrees Celsius, right, or degrees Fahrenheit.
Yeah.
0 degrees Celsius isn't no temperature, it's a specific temperature, right? So we can't say that 50 degrees is half of 100 degrees, right? The number is a half, but it doesn't really make sense, right? We can say that 100 degrees is hotter than 50, which is hotter than 0. Right? So this is interval data. Now, interval data lets us do a few more things than we could with ordinal. As well as being able to calculate the mode and median, we can now calculate the mean temperature. That's okay. And we can also calculate things like the range, the minimum and maximum temperatures for a certain window, right? So that's pretty useful. Another good example of interval would be pH level, right? Again, a pH of 0 means very acidic. It doesn't mean there is no acidity at all or no pH at all. We can say that a pH of 13 is higher than a pH of 7, is higher than a pH of 3, right? And we know how far apart these numbers are, but we can't necessarily say if one is double another one. So the final kind of data we're going to look at is ratio data. So this is exactly like interval, except we now have a sort of true 0 value. So a good example of this would be degrees Kelvin, right? So Kelvin has an absolute 0, which is the absolute average absence of any...
Okay, did I pre-watch or did I pre-watch? You may never know. How did I know he was going to go there? Am I a genius? Am I just, you know, objectively perfect? No. It was just naturally followed from his degrees examples. Or did it? Maybe I am perfect. I'll shut up now. Let's keep going.
kind of heat, right? And then it goes upwards. So we can say that in terms of Kelvin, 100 is half of 200, and so on like this. And we can get to 0. Another example will be number of children, right? 0 children means the absence of any children. And you can also say that, let's say 4 children is double the amount of 2 children, right?
Wait,
And
how did we
two
get to children? I'm sorry, I was writing my note. What is...
Another example will be number of children, right?
Okay, sure. Calvin is ratio data, number of children. All right. So ratio data is, I guess, data with an absolute 0, I guess, is how he's defining it. I guess. Come on, do the thing.
0 children means the absence of any children. And you can also say that, let's say 4 children is double the amount of 2 children, right? And too many to look after, in my opinion. So that is an example of ratio data. Right? Now, ratio data is quite similar in terms of what you can calculate to interval, but it allows some more complicated statistical measures, such as t-tests. So these are the types of data. Now, actually, it's quite important.
Do you know what a t-test is? I don't. Oh, my goodness. Okay, so t-tests. T-tests. Allows t-tests. T-tests. Whatever that is. Perfect. It's just perfect. Okay. Now we're going to move on to the next part of the video.
How you structure your data in general. We can't just have it sitting in some massive spreadsheet with no thought given to where everything is, right? There's
Why not?
actually a pretty standard way of doing this that we're going to look at. Data comes in lots of forms, right? With different types of measurements, different experiments. People are going to collect it in different ways, but actually there's a very standard way that we use to represent data once it's actually on a computer. So we can have some kind of table of our data. We almost always represent our data in a matrix like this, a 2-dimensional table, because it's just much easier.
I don't care what anybody else says. If you want to understand the matrix, this is the place to actually go. Here on this channel, Mind of Meaning, we want to see through the matrix. Okay? We want to see through to the truth. This is the channel that represents real truth from the foundations, data on up. Yes. 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 All right, I'm done.
Easier to do. And so along the top, we're going to have our attributes, right, which are the things we've been measuring. So an example would be maybe we're collecting data on people, so we could have name, that would be some nominal data,
Yeah.
and then, age, height.
Okay,
So
sure.
the columns are attributes, or the things we've been measuring. The rows, those are the instances or the samples.
Okay, so he's saying... All right, so as an extension, we're going to just do a little tabby here. As an extension of this, we are representing data in tables. Tables. Or it is common to represent data in tables where the header is the attribute attributes and the items beneath the header are instances of that attribute. Cool. All right.
We've got. So that's all the individual people. So here's person 1 and person 2 and person 3. Person 3 is called John, and they're 54, and 5'11" or whatever, whatever, right? And so on. And you can have as many rows as you want. So when we talk about attributes, we're talking about the number of columns. People use lots of different terms for these, right? I like to think of them as features. Attributes is another one, and we have instances or samples down the rows.
Properties?
Now, quite often on the very last column of your data, sometimes separated out, but not really important, we'll have our output. Maybe we're trying to make a decision based on these people. Maybe these are candidates for a football team and we're saying, you know, are they going to be on the team or not? So this is yes, no, John's made it, yes, no, no, and so on, right? And that way we could perhaps analyze our decision-making process and decide, you know, is there any aspect of these things that inform our decision-making process, as an example. Right? Now, we always structure data in this way, but if we don't, it becomes a huge problem because you end up spending all this time formatting and trying to work out what's what and, you know, why is John listed down the table and not across the table, and, you know, nothing makes any sense anymore. Right? So
I feel like this guy doesn't have the best arguments. He's saying things don't make sense. Things won't make sense because they don't make sense. Tautological. He's not really giving me information. He's just sort of saying stuff. And, like, I get what he means, right? Like, when things are normalized, when they're conventioned, right? When they're stuck within some kind of a convention, it's, I guess, easy to interpret. It facilitates ease of interpretation. So that's what he means. Like, if you have to constantly reinterpret the same thing because things are being used in different ways, like, yeah, it gets tricky, sure. Okay, we'll just take that to mean what he means.
let's look at an actual data set and we'll see all this in action. So we have here a data set of whether someone goes to play tennis, right? And whether or not they go is going to depend a little bit on what the weather conditions are, right? So we don't like to play, for example, when it's too hot. The tennis data set is just the same structure as the data set we looked at already. We're going to load it in R. It's held in a CSV file. So tennis read.csv. Tennis. Now, we're using R for this because it's free and it has a load of decent functions for analyzing, examining, visualizing data, right? So we're going to be using it throughout these videos. Obviously, you could use MATLAB or Python or some other library if you wanted to. I think that you should use whatever you're most comfortable with.
When looking at these rows and tables, I mean, it looks a lot like something like Microsoft Excel.
You could do this data analysis in Excel. Some people would disagree. No, Excel's perfectly good for what it does. You could do this data analysis in it. I think that Excel doesn't enforce anything to do with observations versus variables and things like that. These are distinctions that are not really made in Excel. Obviously, if you enforce those rules yourself, that's going to work, but you have to be a little bit more, regimented and rule-based about it. I think the consensus would be that if you really want to get into data analysis and start doing things like principal component analysis or more advanced statistical measures, something like R or Python is going to help a lot more. Okay, so I've loaded the data set, and if we look at the data set, so we look at the top few rows of the data, you'll see that there are 6 different variables or 6 attributes, and this data set has 14 instances or observations. R calls them observations. So what we're saying is we have 6 columns and 14 rows, right, of our data set. And this data set is structured exactly like this people data set that I was looking at a minute ago. So we can examine a single instance. We can say, what is it about day 3? So let's have a look at day 3. So we can say tennis on day 3. And we can say that on day 3, it was overcast, the temperature was only 5 degrees, the humidity was high, there wasn't any wind, so they decided to play tennis. Right? So it's a bit chilly, but I guess they gave it a go. So we could also look at all the different temperatures, for example, all the different forecasts, tennis $outlook, right? And we can look at all the outlooks in the data set. So we can say we've got sunny, sunny, overcast, rainy, 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 and so on. And you can get a feel for what kind of weather we're looking at here as well. Using something like R, you can examine the instances, you can examine the individual attributes.
All right, so he's just going into, okay, so this,
and then you can start to drill in.
This video is actually about data analysis, right? We haven't gotten to the analysis part yet. We may never get there. We may be stuck here forever, just down the rabbit hole of what data even is. Doubtful, but maybe. Who knows? So he's just giving an example of like how you could analyze some data given what he's already said before, which is fine. That's fine. That'll be just dandy for him. It looks like he's going to go over a little bit more details at the end here, and I want to see what that's about. So we're gonna follow this thread right on to the end.
Into what this data set means. Now this data set has in it the final column, which is whether they actually played. So you could use something like machine learning to predict that final column based on the other columns. That's something you could do. One other thing about this data set that's quite interesting is it has a few examples of the different kinds of data we were looking at earlier. So remember, we have nominal, ordinal, interval, and ratio. So
Okay.
for example, Outlook is really a nominal field, right? It's a nominal data type. You could perhaps suggest that you could order it from rainy through to sunny, but then cloudy, overcast, it doesn't really make any sense. So this is kind of nominal. You could calculate, for example, the mode and say that most of the days were rainy or something like this. Temperature, right, as we discussed before, this is in Celsius, so this is going to be interval. We can order the data and we can say that one of them is 50 away from another one, but we can't say how much of a difference that is. Like, is that double the temperature or half the temperature? We can't really say. So humidity is ordinal, so we can say high is more humidity than normal, right? But we can't really say how much. That's going to depend on who was measuring it and where their differences lie. And finally, wind in kilometers per hour. Well, 0 is no wind. Yeah, you can't have negative wind. So this is a ratio, right? You can say that 20 mile an hour wind or 20 kilometers an hour wind is 2 times more than 10. Right? That's something you can say. This little data set contains all kinds of data. So the different statistics and measures you can calculate using these is going to depend on what kind of data they are. So we can see that even a very simple data set like this has loads of different kinds of data and different ways we could interpret this data. Right? If you make a decision to play based only on whether the outlook is good, you're maybe not going to solve the whole problem, right? So these are the kind of things we'll be looking at as we go forward. And one thing we might do next is to visualize this data, start to try and understand some patterns or extract some kind of knowledge. It's a very important tool, but you've got to...
Okay. You get all that? Okay. So, this was a computer person's view on data, right? We've got some information here. Information. See, it's hard to escape, right? It's hard. We're using the thing to interpret it, right? But we're making progress. So, okay. Here's the thing I want to do. I want to try and take each one of these definitions and write it in my own words. And I recommend, if you are following along at home, if you are finding this content enjoyable, if you are enjoying the process here, I recommend you do this as well. And also, go over to patreon.com/mindofmeaning and support me over there, because I would love that. I would just love it. It would be wonderful. Yo, look, it looks like someone actually messaged me on the Kicks. Hold on. I need to respond. Good old chatties. Lol. True. Is this an actual learning stream? Yes, we are here to learn. I am probably the only... Oh, God. It always does this. Okay? Yeah. Hold on. You can't even hear me right now. Can you hear me? You can't. You can hear me. Perfect. Okay. Yeah. This is probably the only learning stream on Kick. So if you wanna get in on the ground floor, support me on Mind of Meaning, patreon.com/Mind of Meaning. Get that sweet learning money, learning knowledge, learning whatever. Listen, shut up, okay? Some of us are here to learn, okay? Some of us want to be more than miscreants and degenerates, okay? That was just Kick Chat, right? I'm sure the YouTube audience is more innocent because they are just non-existent as well. Anyway, so here we are. Definition of data from Wikipedia. In common usage, and statistics. Data blah 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 is a collection of discrete or continuous values that convey information describing the quantity, quality, facts, statistics, other basic units of meaning, or simply sequences of symbols that may be further interpreted formally. Okay, let's have a think here. I already gave my definition before, right? I said data is to, or what information is to the finished product of that ore. So like silver ore to like a actual silver. I don't know. Is a collection of discrete or continuous values that convey information, describe the quantity, quality, facts, statistics. This all seems like very complicated. Let's just say well, now my camera's messing up. What if I do I don't know why it does this. Oh, I think my computer might be freezing. Okay. I'm gonna see if turning my camera off fixes the problem. Until then, enjoy the very cyberpunk look. No? Maybe? Potentially? I love you. Okay, that's fascinating. Okay. Alright, looks like I'm gonna need to come back because my OBS is not responding. Love that for me. Anyway, if you've enjoyed this content, thank you for joining in here. I'm gonna just restart my stuff and hopefully figure this out. All right, until we meet again, goodbye.